Okay, we're going to take one log function and turn it into multiple log functions, or we're going to take multiple log functions and condense them down to one. So what I want you to see here is that your multiplication, whenever you're taking the log or natural log of two things that are being multiplied, you break that apart by addition. When you have division, you break them up with subtraction. And then when you have exponents, you make them coefficients. Okay, so I'm taking the log base 4 of 5 times x cubed times y. So we can break it up by multiplication first, or break up the multiplication first. Multiplication goes to addition. So I'm going to keep log base 4 for every one of these, plus log base 4x cubed, plus log base 4y. The only one I can keep expanding, this one stays the same, is this middle one, because it does have a coefficient. Bring that out front. The way I remember it is that coefficient takes up more space than an exponent, so that's the expanded version. Log base 4x plus log base 4y. Okay, let's practice some more expanding. This first one, I would like you to try it on your own, then watch. I've got three things being multiplied, 3x squared, then y. So this is log. It doesn't have a base. It's assumed to be 10, but you don't have to write it. Log 3 plus log x squared plus log y. This one can go one step further. Log 3 stays there. 2, oops, that was supposed to be a plus sign. 2 log x plus log y. Okay, and the same rule applies to natural logs, but what I want you to understand is this is when you have a square root that can be written as a power of 1/2. So what I'm going to do is break up the division first. You follow your order, your order of operations. How can you break it up? Like, I couldn't go straight for breaking up this addition. It's embedded inside an exponent, and it's on top of a division. So I've got to break up my division, then fix my exponent, then break up my addition. Okay, my division goes to subtraction. So this is the natural log of 4x plus 1 to the 1/2 minus the natural log of 8. I'm going to pull my exponent out, 1/2 natural log of 4x plus 1 minus natural log of 8. And I did misspeak. Since we are expanding, you do not expand anything with addition. It is already expanded as far as it can go. You can only expand multiplication, division, and exponents. Okay, let's go the other way. Now I'm going to take anything that's being added and take it to multiplication. Anything that's being subtracted, take it to division. And anything with a coefficient, I'm going to make an exponent. When I look at this first example, I'm going to be able to take my coefficients first, make them exponents, and then the only other thing I can condense is this big addition. Now I want you to know that this subtraction in here is inside. We can't get into that. The only way we can get into these is if they're multiplying or divided, and that's only to expand it. So this is what this is going to look like. Log of x to the 1/3 plus log of x minus 3 to the 5th. And then I can condense this big addition into multiplication. I'm going to keep one log x to the 1/3 times x minus 3 to the 5th. And over here to the side, written a little more clearly, log x to the 1/3 x minus 3 to the 5th power. On this next example, you can see your coefficients, bring them up as exponents, then condense the subtraction. You can't get in here. That is already condensed enough. So natural log x minus 4 to the 4th minus natural log of x squared. Subtraction goes to division, so this is the natural log of x minus 4 to the 4th over x squared. Okay, last example, 1/5 is going to become an exponent on everything. But I think before I do that, I'm going to condense this addition in here. Because if I put my 1/5 out here, I can't exactly just bring that 1/5 power in because of this addition. So I'm going to keep my 1/5 out here. I'm going to condense these two logs. They're both log base 3. They're being added, so I'm going to condense them to multiplication, x times x minus 2. Now I can take my 1/5 out to make an exponent, and I won't have to do any distributing. Log base 3 of, and you could even multiply that if you wanted to, x squared minus 2x to the 1/5 power.